Australia is famous for its high reptile diversity, and particularly renowned for its many venomous species, especially snakes. But why is Australia so different to other continents worldwide? We speak to Dr. Chris Jolly from Macquarie University. Chris is a zoologist interested in reptiles, conservation, ecology and evolution. Chris, Australia is renowned as a global hotspot of reptile diversity. Can you explain to us why Australia has so many of these species?
Yeah, that's quite an interesting question because Australia does really dominate the globe in the number of reptile species. We have over 1,000 reptiles, most of them composed by skinks and geckos. And there's a lot of factors that contribute to it. It's no one reason. But a large reason for the diversity of reptiles in Australia is the continent's long-term isolation from the rest of the world. For about 40 million years, Australia has been isolated from the rest of the other large land masses. And Australia is a very dry, hot continent that has been stable for a very long time. And that is the sort of environment and habitat that reptiles thrive in. The other component to that is that there's very few, and at least until very recently, very few eutherian mammals in Australia. So the mammals that we have had historically have mostly been marsupials until rodents and bats came in a bit later. Reptiles have had very little competition from larger mammalian predators. So they've filled a lot of these niches that are filled by mammals in other countries. But we've just got such a vast, diverse area of very dry and variable habitats. We've got the tropics, we've got the arid zone, we've got the alpine regions, and each of them has a different subset of reptiles that exploit those environments and fill the many niches. And so that's why we have so many reptiles in Australia.
Yeah, and of course, when talking about Australia, the first thing comes to mind are all the venomous species, especially the snakes. Can you perhaps explain a bit more why Australia also has so a high diversity of highly venomous snakes?
Sure. So yeah, Australia does have a lot of highly venomous snakes. In fact, unlike most other countries in the world, the majority of Australian snakes are venomous. In other countries, colubrids and non-venomous snakes compose most of the diversity. In Australia, most of the diversity of Australian snakes is elapid snakes, which are front-fanged venomous snakes. And the reason that group has radiated and filled a lot more niches and become a lot more diverse is because they haven't for a long time had competition from other groups. So we have pythons in Australia, but colubrids came a lot later to Australia from Asia. So elapids didn't have the competition of those snakes very early on. Why are Australian snakes so extremely venomous? Well, most of them aren't, but there is a few species that are incredibly venomous. And venoms evolve for prey capture. So when you live in a large arid landscape where prey is scarce and your next meal is unpredictable, there's a strong evolutionary pressure for you to be able to disable that prey before it runs away and do it very rapidly. The other problem with prey is that they can be dangerous. So rodents, if you don't kill your rodent prey very quickly, it has the opportunity to kill you. So things like inland taipans, for instance, world renowned as one of the most venomous snakes in the world, potentially the most venomous snake. They live in the Channel Country of central Queensland and northern South Australia. And this is one of the most harsh landscapes in the world. Most of the biodiversity that lives there lives underground in soil cracks and persists through decades of drought and lack of food. When it comes across its primary prey target, long-haired rats, Rattus velocissimus, it needs to be able to subdue them really quickly, and so that it can do that uninjured and without losing its prey. Another aspect is the arms race between prey and predator. So as predators evolve more toxic venom, prey adapts by becoming more resistant. And so there's this continued tug through evolutionary history of resistance matched by increasing venom toxicity, resistance, increasing venom toxicity. And unfortunately for humans, we are very similar to rats. So it's just a quirk of nature that taipans that are extremely venomous, and their venom is designed to subdue their rodent prey, also has the unfortunate effect of being highly toxic to humans.
Chris, coming back to reptiles as a whole, you mentioned this already, that reptiles really like it or are very sensitive to temperature and probably also changes in temperature. With ongoing climate warming, how might Australia's reptile species be impacted?
Yeah, so as most people would understand, unlike birds and mammals, reptiles are ectotherms. So their bodily functions, all physiological functions, reproductive functions, are driven by body temperature. In mammals and birds, that's driven by physiological processes that maintain body temperature. Reptiles can't do that. Their temperature is entirely dictated by the environment. So on a cool day, they will come out and bask in the sun to warm up their body temperature so that they can go about their daily activity. And on really hot days, when they can't maintain their temperature above critical level, they will shelter in cool places to stay below that maximum temperature. So what we're likely to, and because of that, reptiles are adapted to a thermal niche, and they shuttle around the environment to maintain their optimal temperature for different physiological functions. What we're likely to see with climate change is that these temperature envelopes that these species exist in are going to change. They're going to move through space and move through space very rapidly. So reptiles and all species aren't just adapted to a thermal niche, they're also adapted to a habitat niche. So if those temperatures associated with those habitats become misaligned, and suddenly the habitat they're associated with is no longer associated with the temperatures, they either have to move, or if they can't find that habitat that they rely on, there's a mismatch there, and their distributions change and alter and possibly disappear. And yes, so they're very vulnerable to temperature. Another quirk of reptile reproduction that is likely to be impacted by climate change is that some reptiles, such as turtles, have and crocodiles, have temperature-dependent sex determination. So the sex of the young forming in the egg is dependent on the temperature at which the nest is incubated at. So over a certain temperature, it would either be male or female, or vice versa. So as we see shifting temperatures, unless these animals adjust their nesting habits behaviorally, so say dig deeper to account for increasing temperatures, we're going to see this sex bias in the outcome of nesting, which will, if you have a population entirely dominated by males in a sexual reproducing species, that's a really big problem. So the impacts of climate change are really multifaceted, and it's unclear how they're all going to play out at this stage. But I suspect for everything, rapid anthropogenic climate change is going to be a bit of a problem.
Chris, you're a highly active early career researcher, already well established in academia. Is there anything you would wish to have known earlier? And is there any advice you'd offer to other emerging young researchers?
I don't think there's anything that I particularly would have wished to have known earlier, but one bit of advice that I've sort of lived by, and it's proven quite successful for me. And when I look around at all of the early career researchers that are succeeding, it's to follow your passions, to be as motivated and productive as you need to be as an early career researcher. You have to be passionate about what you do. And it's much easier to follow the things you're already passionate about than try to artificially manipulate passion in something that you're just simply not that interested in. The other thing is to have a grasp of what you are good at, what skills you bring to the table, and also understand your weaknesses. And the weaknesses aren't a problem. The weaknesses are easily filled by having a big collaborative network and maintaining connections between people who you know can help you on your academic journey. So if you're an excellent writer but not particularly good at stats, then make sure you're collaborating with people on projects that can buoy up your weaknesses. And you know, collaborative teams are really what makes great research, not any one individual.
Awesome, Chris. Thank you very much.
No worries. Thank you.